right away. So first of all is to welcome you. People who are not there for the other class, I just want to welcome you, and I'll just be able to give you still an overview of what degree and order of a differential equation is. Then you can be able to move from there. So let me link up some screens so at least you can be able to see. So I'll be writing almost like a class. So this is what you should be seeing in my board. Let me, it is still refreshing. Yes, it is there, my board. So I'll start on an overview what an order is, what an order of a differential equation is, and a degree of order. Order of an ODE. So basically, it is how many, the order of a differential equation is the highest ordered derivative, is the highest ordered derivative, highest ordered derivative, in a ODE. And for me, the ODE means ordinary differential equation. So it's the highest order derivative or in an ODE. Basically, let me give you an example just to demonstrate that. For this one, the order. Here the order, basically it will be, we have y and we have dy dx. So basically in this equation we have been able to differentiate y in terms of what? In terms of x only what? Once. This one is only one. So the order becomes one because that is the highest order. Just becomes one because it has already been differentiated once and this one is the highest what? Ordered derivative. So it becomes number one. Type something if you can be able to get what I'm saying. Type something if you can be able to get what I'm saying. Kaimba Masinde, I don't want you to see a video. I want you to see a board of I writing something. So the order is one. Type something. Type something if you are okay with that. If you can be able to see my board and at least you can be able to hear me. Hey, Mwandiki, ataka mwandike, just write something. If you are following, if you are okay. Ferdinand, you're not writing anything. Kameti Kuti. Mukenya Leonard, can't see anything. I'm waiting for you to be able to. I cannot be able to proceed unless I see. At least you can be able to see what I'm typing. Can I proceed? Yes, Mukenya, can I proceed? Can I proceed? Mukenya? Can I be able to proceed? Can I proceed? It's as if we are not. Let me. Yes. We are on order and degree. Karacha Kelvin, confirm if you can be able to see my board now. So at least we proceed. Okay, confirm. Okay, sawa. Maureen, confirm about the board. So I'm finding different answers. I'm finding different answers from you. So which is the answer now? So we say you don't go to degree, but you go to what? To order first. So the biggest question will be how many times? I'm waiting for someone to confirm about the board. Okay, sawa. She's okay. So now the degree will be here. The order will be here. Why? This equation has only been differentiated only twice. This one has been differentiated how many times? 4 times. You can be able to see the 4 is more than 2. Honestly, if you have 4 chapatis and 2 chapatis, 4 chapatis are more. So this one becomes order of number 4. Basically, we go now to the order. The order is here. This order has been raised to which power? Has been raised to power 2. So the order is 4, the degree is 2. This one doesn't matter, this one, the 5 doesn't matter. Why? Because this one is not the highest order derivative. So you may be able to make that confusion. So that's why I was saying you go first of all to the order. Where the order is, the degree will be there. The power is not at for anyone. You don't just go to the highest power. No. You go to the highest order derivative. It is of power 2. Is it a bit clear? Is it a bit clear for that? Let me do another one. People who had at least a problem with the board, they can be able at least to do this one. Let me do another one to see. So we have d squared y all over dx squared raised to power 7 minus the power 10 Give me for that one. Give me the order and the degree for that one. Give me the order and the degree for that one. Another example I've been able to give me the order and the degree for that one. At least I have one. At least I have one answer. I'm waiting. At least I have another answer. I love the answers for now. Okay. So I'm waiting just to hear from the rest. The order and the degree for what you can be able to see on the board. Okay. I'm loving at least 4 answers are okay. 5, 6. Okay. Algalo Dima, welcome. I can see you are typing. Okay, give me the order and the degree for that one. Calgalo, order 3. No. Calgalo was doing the same mistake the people did in the previous example. So I'm waiting now for 2 people who had a problem with the board. Maureen, you have gotten it. Okay. So I think we are good. I'll only demonstrate to Galga. So Galga, we had said order, you go first of all to the highest order derivative. The highest order derivative, we have power 2, we have power 3, and we have power 4, and we have just the y. So you can be able to say the highest order derivative is where? It is here. That is the highest order derivative, that is 4. And then the degree now, the degree, we don't go to any other one. We go back to this order. This one that has been differentiated 4 times. It has been raised to which power? Only power 1. So the order is 4 and the degree is 1. So don't go to the one that has been raised the highest power and check. No, the degree comes after the order. So maybe here a note, degree comes after order. If you identify the order, then you have gotten the what? The degree. Anyone with a question so far, I can be able to address it. I can go, okay, so you have been able to understand. Sawa, that's good now. Been able to understand. So, yes, I'm waiting for confirmations if we are okay. Variables. Separation of variables. Separation. Variables. So again, these are given some notes on last. Many people are saying they were not understanding, so I need at least to revise some of them. So we have dy dx is equals to x. So we are solving that one. So we want to solve that differential equation. That is the first one. So how do we solve such an equation? And we came up with a separation of variables that we are supposed to take the y on one side, take y on one side, and x on the other side. This is the first one. That is number one. Take y on one side and x on the other side. The other important step is to know that dy and the x have to be on the numerator. Yes, very important. So take y, that is the equation dy over dx is equals to x. And then we have, so we are saying the first one is take y on one side and x on the other side. Then we have said that dy and dx have to be on the numerator because we shall be able to come and integrate. Then number 3, the final step is just integrate now. After you have been able to do that, you just have to integrate. You have to remember some integration, then integrate. And I'll be able to do this first example. So we have dy over dx is equals to x. We want to solve that one using separation of variables. Take y on one side, we shall do that one, and x on the other side. And then we shall have dy and dx have to be on the numerator, very important. And then we integrate. And let me do this one. So solution now for that one. Solution. So we had dy dx was given by x. So we have said that x, everything that has x has x dx. And then after doing that, then, because you can be able to see the x is on one side and the dx is on the other side, they are together, and we have different, not be able to integrate. When you integrate dy, you are supposed to get y. When you integrate x, you get x squared, add 1 to the power, divide by the new power, and then you add a constant of what? Integration. Only that. And you are done with the equation. So y will be given by x squared plus 2 plus c, like that. So take the x with the dx, take the y with the dy, and then you are done. Let me just demonstrate another one before I ask for questions. Number 2, dy all over dx is equals to y. So again, another good example. So you can be able to see that first of all, I'll cross multiply this one to come this side here. So at least I can be able to have at least dx on the numerator. So I'll have dy will be given by y dx. The first step I'll be able to do. But if you can be able to see, y and dx, they are not similar. So I have to take this y this side. So I must be able to come and divide both sides by y to remove the y on this side. So at least the y can go with the dy. And I cancel that one. So the y has gone with the dy. So I remain with the dy all over y is equals to what? Dx. Then now I come and integrate. You can be able to see the y and the dy, they are together. Then I come and integrate. When you integrate 1 over y, you'll get ln y. When you integrate dx, we always get x plus a constant of integration. Are we together, class? Yeah. Sorry for that. Network problems. Sawa. So I have to repeat all again now. So again, I'll have to start separation of variables. That is where we are, separation of variables. So we have dy, we want to solve dy, all over dx is equals to x. Can you be able to see now the board now? Okay, so clear now. So we have dy over dx is equals to x. You want to solve that, and we have said take y on one side and take x on the other side. So when I say y on one side, I mean even with functions of y and function of what? X. That is the dx and the dy on one side. Then we have said that dy and dx have to be on the numerator. Very important. And then after we do that, then we can be able now to do what? Integrate. I have the first example, the solution for the first example. So I have dy over dx is equals to x. So I take this first of all dx on the numerator, and you can be able to see I'll get what? Dy is equals to x dx. You can be able to see that x and dx, they are together, they are of the same kind, so there's no problem. Then I do now the integration. When you integrate dy, you get y. When you integrate x, add 1 to the power, and you divide by the new power, and then you add a constant of what? Integration. So you can be able to see x and dx on one side, and then dy on the other side. Now I did another example before the board went dark, this other one here. Dy all over dx is equals to y. That one there. So this other one, dy over dx is equals to y. The first thing I did is to take the dx on the numerator. That's the first, because it was on the numerator, so I was able to cross multiply. So it came there. But the problem, I had a function of y here. How do I remove it? I divided both sides by y. I divided both sides by y. The y and the y cancelled. And I remain with what? Dy all over y is equals to dx. When you integrate 1 all over y, you'll get ln y. When you integrate dx, you'll get what? X plus c. And you are done with that. So that is basically the answer that you'll be able to get. I can still move a bit further this one here. Remember, I had told you ln and the exponential, they have a relationship. If you want this answer in terms of y, in terms of y, in terms of y, I will introduce exponential in the exponential function. So if I want that answer in terms of y, instead of ln, I'll introduce the exponential function to be able to assist me. So how do you introduce that? Check this one out. So introducing the exponential both sides, ln y is equals to exponential x what? Our answer was what? Oh yes, it was x plus c on the numerator like that. Now, exponential ln y, this one will always go to y. This one I can be able to use the laws of indices, exponential c, and then times what? Times c. Because when you have a positive power, you're supposed to multiply the same. But I can be able to call this one another letter. This one because it's still a constant, so exponential c to be d. That's why you have y will be given by d exponential x. So I think you'll be able to see this one in some books. If you want to present your answer in terms of y, you introduce exponential, and remember exponential ln y, you remain with y. And then this one using the laws of indices, I can be able to separate them. This one is still a constant. This one, I can call it a constant d. And some of the books, they have been giving you answers like that. Let me hear reactions, if it is clear or you need more clarification. I want to do more examples of that. If it is clear or you need more clarification. I want to hear people typing. Okay, so I can be able to do. Sorry for that. So you can be able to see I have a function of y and a function of x with the x and dy on the other side. So how do we crack that one out? This is what we shall be able to do. I'll take this x to come on this side, then I'll take this y to come on this other side. So at least we have same functions together. So if I do like that, I will end up with dy all over y is the same as what? Dx all over x. If I do like that, then I will integrate, integrate, because now we have similar functions together. I'll have dy all over y is equals to dx all over x. Let me hear some answers. When you integrate, what do you think you'll get? Integrate dy over y and dx over x. Let me hear some answers. Want to hear some answers? When you integrate that one, oh, my board cannot be seen again. Let me share again. There's an issue with this big blue button. I'm sharing the board again. Okay, there it is. Sorry for that again. So I was saying, you have been given x dy is equals to y dx. So x is with dy. So we have a problem there. They're not of the same kind. Then we have y and dx. Again, we have a problem on that side. So what do? I took the x, I divided here by x, I took this other side, it will go on the denominator. Then you take the y, again it will go on the denominator. Then after you do that like that, then you integrate the two. Because now we have dy on y on one side, dx and x on the other side. Check again what I have. So x has gone on the denominator of dx, y has gone on the denominator of dy. Then I've been able to integrate both sides. And I was asking you, when you integrate dy over y, what will you get? When you integrate dx over x, I wanted some answers from you. So let me here. You can't see the board. I think I've reshared the board. I want the answer for dy over y is equals to the integration of dx over x. You can't see the board. Thanks. But I'm seeing some people are seeing the board. Bonyo, can you be able to see the board now? Let me hear some answers. Because I've been able to reshare the board. Kamba Masinde, you have given me only one. Give me is equals to what? The answer on the left hand side and the answer on the right hand side. So far, no one has gotten it. So far, no one has gotten it so far. I say layer y is equals to x. No. Florence Ongai, ln y is equals to ln x. No. Masinde, ln y. No. You have given me only one. Karacha Kelvin, ln y is equals to ln x. No. Yeah. This one is now interesting now. Okay, sorry, you can be able to see me. Okay. Give me that answer. Dy over y, and then is equals to dx over x. No one has gotten it. If you had given me the answer before, you can try again. Yes. So far, no one has gotten it. So far, no one. ln, okay. Kaimba Masinde, ln plus c. No, that's incomplete. Christabel, you are not writing anything. I can be able to see you. You can't write. Write something. Hey, can't. I'm waiting for the answer. Someone has gotten it now. Now I am okay. Sorry, Florence. You are almost getting it, but you missed a small bit. So this one is the answer. Let me give you. So this one, when you integrate this one, so this one, remember this one is the same as, if you want to see it clearly, it's the same as that. 1 over y dy is equals to integration of 1 over x dx. Remember when you integrate 1 over x, we did that one in calculus, you get ln. So you get ln y is equals to what? Ln x. Plus a constant of integration, Florence. People are forgetting the constant of integration. Please don't forget the constant of integration. So that is the answer. So don't fear, it is not that hard. But this one I'll be a bit needy. I think there's a time when we are doing, when we are introducing a constant of integration, I will not love this one. When you have ln y, when you have ln y, ln x, call the constant, call the constant what? Someone who can be able to remember this? When you have ln y and you have ln x, I had said something. What do you think we shall be able to call the constant? Okay, sawa. ln c. Yes, that's important. ln c. So the best answer I can be able to have is ln y is equals to ln x plus ln c. Why am I introducing ln c? Because I can be able to simplify this one. Introduce ln c, introduce ln c for simplification purposes. Check this one out. You remember the law of logarithms. When you add logarithms, what are you supposed to do to them? You remember this one? Ln a plus ln b. This one is supposed to be ln ab. When you're adding, you introduce multiplication. So I can be able to simplify this one as ln y is equals to ln x and then c. For easier simplification, that's why I was introducing both sides. And for this one, I can be able to introduce exponential both sides. Exponential both sides. Check this one out. Both sides. Introduce exponential both sides. I'll have what? This is what I'll have if I introduce exponential both sides. I'll have e ln y is equals to e xc. And then this side, e ln y, you say this one is the same as y. E exponential c, can I be able to nini? Should just remain like that. I don't think there's another way I can be able to simplify this one. It should remain as that. So exponential xc. And I believe you'll be able to see some answers like those ones. So when you reach here, let me go back. Instead of introducing c, we have said we introduce ln c for simplification. And then after introducing ln c, we can be able to use some laws of logarithms. When you have ln a plus ln b, that is ln a b, you can be able to multiply them. And then introduce now the exponential both sides, and we'll end up an answer like this one when you check at some books. Or exponential cx. I think there are some books they are giving like that. Let me hear from you. Is it a bit better? Multiply. Let's see. Kelvin D. No, it was Nini. I'm asking if you have been able to understand why we're introducing LNC. LNC and the simplification that I've done so that I can be able to introduce LN. Because when you have the C, you can't multiply the logs together. Okay, so thank you for that. These people are responding. They've been able to understand. Let me do another example. Check this one out. I don't know if it is number 4. Dy all over dx is equals to 4xy. 4xy. And then I give you here some nini y what? y2 is equals to 1. Like be able to explain what I mean. So you have been given dy all over dx is equals to 4xy. Now this one here, and I'll start from this one. This one y2 is equals to 1. I'll ask you first of all, because I think we have done something like this one. What does it mean? We start from there. Let me hear from you. What does it mean? No. Florence Ongai, it is not possible to take. Let me go back. Florence, we can only take the constant outside here if you have either addition or subtraction. When you have addition and subtraction, you can be able to separate. But like this one, you cannot be able to separate. When you have times, you can't separate the two. But when you have addition, that is the time you can be able to introduce a D. But like that one, you cannot be able to. So this one, you cannot be able to separate. So avoid y is equals to exponential x, exponential c. They are not the same. This one means what? Exponential x plus c. It's different from xc. So that one we avoid that one. Not like the other example. If I go back to the previous example just to explain what Florence is asking, check this other previous example what we had. Let me go back. Let me go back. You see, yes, now here check. We had what? We had x plus c. Now x plus c, it is possible to do what? Dissect into 2 because it is addition, you multiply. But this other one, you cannot be able to. You cannot be able to this other one. Yes, it is not possible to do this other one. Possible to do this other one. So please don't separate the two. It will remain like that. That for that one it will remain when you're multiplying. Yeah, let's go back to number 4. We have that one dy over dx is equal to 4xy. Someone to tell me y into brackets 2 is equals to 1. What does it mean? What does it mean? Y into brackets 2 is equals to 1. Someone to try. Hakuna mtu anataka kujaribu. Someone to try y into brackets 2 is equals to 1. What does it mean? Because I know there are some problems like this one you have been given. Y is equals to a half. No. Thank you for trying, Faith. Florence, y is equals to 2 and x is equals to 1. No. Another person to try. So let me tell you what it means, because you can't proceed unless you know this one. So this one means that y will be 1. That y will be 1 when x is equals to this other one. When x is equals to 2. Florence, you are interchanged. So y will be given by number 1 when x is equals to 2. So whatever that is here is for the value of x. The y is the one that is giving us number 1. Okay. Now let's do this example now and see what our answer will be. So say this one is a separation of variables. We can't integrate first. The dx is where? On the remove the dx here. The first thing. So you take that dx there, this is what I'll get. Dy is equals to 4xy, and then all over d what? Dx. That's the first step you do. That's the step number 1 we have done. Step number 2, we need now to do what? The problem, I have a y here. So I must take this y this other side. So I divide. So if I divide, I'll get dy all over y will be given by 4x and then dx. I've been able to take the what? The y on that other side, because it was on the numerator, it will become on the denominator. Then I can be able now to integrate now both sides. Someone to integrate and tell me what they think they'll be able to get upon integration. What do you think you'll be able to get when you integrate that one? My board is still having a problem. It was still clear. Let me share it again. I'm sharing the board again. So a person who is saying they cannot be able to see. Okay, there, the board is there. The board is there. So I wanted at least you to give me the answer for that. So I've multiplied by the dx. It has gone on that other side. Then I had a problem with the y. I've taken it on the side of dy by dividing. Now on the integration part now. I hope the board is clear now. So I've seen one answer. Kirwa, you are only giving me one side. I want to, even on the right hand side. Give me some answers when you integrate that one. Our noted Florence. So you can be able to see most of you, at least two, have gotten it. So this is the final answer. If you are, so this one you'll get lny. You have done that one before. This one you'll get what? 4x squared, and then you divide it by 2 as a constant of integration. There's no need of introducing ln c because there's no other ln for x. So to simplify this one, you get ln y is equals to 2x squared plus c. Now, this value here will be able to assist us to get the value of the boundary condition. Remember the value I've given you. So y 2 is equals to 1 is a boundary condition. Boundary condition to help us get the value of c. The value of c, basically. So that one is the one that will be able to assist us to get the value of c. So how do you check that one? We had said that this one means what? That y is 1 when x is equals to what? 2. So I replace back one in the equation. So substituting, I'll get ln1 is equals to what? 2, and then x is 2 squared plus c. Someone me. So ln1, remember ln1 is the same as 0. Same as 0 from the calculator. So 1 will be the same as, that is 2 squared plus c. Someone to give me the value of c. Someone to give me the value of c. Someone give me the value of c from there. Then 1 is the same as 0. So from there, can someone calculate the value of c? I've seen one answer. Another person. Yeah, Florence, hapana, nimekataa kata. Okay, at least one person has gotten it. Another person to try. I say thank you. At least that's okay. Florence, okay, sawa. Another person to try. Sawa. Sawa. I can be able to say yes. At least 3 people have gotten it. So this one we are getting at 1 is equals to 8 plus c. So c will be negative 7. So now in the final, we go back to the equation what we had here. We had what? ln y. We had ln y was giving us by 2x squared plus c. But now we know the value of c, so the final answer will be what? 2x squared plus 7. We are done with that one. So you can be given the boundary condition to be able to assist you, to be able at least to do what? To get the value of the constant c. If you see such examples, to get the value of c. Let me do one that I remember Florence had a problem with, and then I can be able not to go to another topic now. I think it was going like what? dy? I'm not sure. I've written them somewhere, but I cannot be able to remember. Dy all over dx is equals to 1 plus y squared. So that function imeshikana 1 plus y squared. So how do we solve this one? How do we solve this one? So how do you solve this one? This is how you solve it. So because 1 and y squared, they are together, they are joined, we shall take them on one side. But first of all, let me bring the dx this side, you see. So dy is equals to 1 plus y squared dx. So I'll not recommend multiplying. Please don't multiply because it will not work out. Because if you multiply, avoid. So we can go first of all, avoid. Am I still okay? Let me check. Avoid dy is equals to dx plus y squared dx. Why? Am I telling you to avoid that because of this one here? You cannot be able to remove that one. You have introduced a dx and a y together, so it will not be able to work. So leave it the way like that. Then I'll recommend you bring this one this other side. So you'll have dy all over 1 plus y squared is equals to what? Dx. Is equals to dx. So take the whole of that function on that other side. Then we do the integration now. When you integrate this one, now Florence, I hope you remember this one. You guys will need to go back to calculus in x squared plus a squared dx. This one you're getting as 1 over a tan inverse of x over a. That's what we are getting, tan inverse. So when you have x, y, this one, you cannot be able to integrate by separation of variables, nothing like that. You just have to introduce this one here. Go back just to the mathematical table. So this side now, remember we have this one here. Our a is 1. Why? Because 1 is the same as 1 squared. And then we have our x now has become now our y. So when we integrate that one, we expect to have what? Tan inverse. The tan inverse of y all over 1 is the same as when you integrate dx, we'll get x plus c. So that's where the tan inverse was coming from. The tan inverse was coming from. So this one, the final answer will be tan inverse of y is equals to x plus c. Now, if you want to write the answer in terms of, there's no need of writing in terms of why it will give us a need. But I think with that answer, I think I've been able to answer something that people had a problem with the YouTube. People who did the YouTube, they'll be able to get it. Oh, Florence, repeat, sir. Okay, sir. You can say they repeat. Okay. So we had something like this one, dy over dx is equals to y. So we have said, first of all, we take the dx on the numerator. That's what I've done. Then I've said avoid this one to open up the bracket. When you open up the bracket, you will have a function of dx and y. This one you can't separate. You can't separate that too. So I'll not recommend you to open up the bracket. What I recommend is to take that whole function in the side of what? Y. Because 1 is a constant, it will not be affected so much. So I've taken 1 plus y squared on the side of dy, it has come on the denominator. The dx has remained the way it is. Now I've used a principle on the mathematical table, the integration of 1 over x squared plus a squared dx. This one is by 8 tan inverse of x over a. If you take these two, they are closely related because a is a constant. So if you check that one correctly, our a is 1, is the same as 1 squared, and our x becomes our y. And if you do that one correctly, now you'll get tan inverse of y over 1 is equals to x plus c. Then y over 1 is the same as still just y. That's why I'm finding the answer to be tan inverse of y is equals to x plus c. So you need to go back to table. Table of what? Table of integration. You need to go back to the table of integration if you want to do it correctly. Is it a bit clear now? Is it a bit clear? Okay, so you guys go through the other examples that I've given you an exercise and you will be able to tell me. Imagine now I've been able to repeat last minute. Today I was supposed to go to, I'm supposed to go to homogeneous equations. You'll give me 1 minute. I go and plug my PC and then I continue.
You are now unmuted. You are now unmuted. Kevo, alafu badala unyakapi chakula kitu unasema ni sawa. nasema badala unibaka we hata kuna tulikuwa nasema unangoja tu hivi niambie my answer is wrong. Sawa.
Leo unasema nini wewe?
Akizo kuja na barabara sisikikaji vizuri. Kwanza bado zimewaisha. Sisikii.
Wewe usikii kwani umeweka wapi masikio wewe? Oi, working at home, learning at home. Sasa unaonaje learning at home? Mimi niko shamba nasomea shamba eh? Oi,
Pambana na hali yako ye. Hata niko tu kukaa hapa nisikiliza hizi vitu hata nachoka. Sasa bado zinaisha baby. Anarudi tunaendelea mpaka saa ngapi na saa 7 imefika.
Kwani mnaamua kwenda Kiendanga?
Unasema nini?
Kelvin, what's the problem?
Brian, ulifaulu kufika huko?
Ilifaulu bana after a very long journey.
Welcome bro. Pia mimi nimepitia mashida nyingi bana, acha tu. Hii maisha
Ai
maisha
bana. Ai. Sasa sijui ya kesho nitafanyaje ndio nisumbue.
mimi nimetumia pesa ya 200 kununua bundles bana kwa hii kitu ya ujinga. Ai,
Alafu bwana ameenda hawezi rudi.
tunashangaa na class nitakaa niisha 1 bana. Kwani sasa ni saa ngapi?
Hebu soma huko juu amesema from 11 hadi 2.
From 11 to 1, acha ujinga.
Si amesema sijui ameongelea sijui ya black sijui nini bana busy yake.
Alichelewa kuingia. Sisi tulikuwa class, hata kama tuling'ang'ana class itakane iishe bana.
Alafu unaonaje attendance yako?
Oi.
Yeah?
Hata mimi ndio nilikuwa nakuuliza, hata mimi sioni. Ndio nataka niulizie hapa. Hebu Flo kuja hapo utusaidia hapa. Hello.
Nasione watu kama kina Paulo.
Oi, hata.
Have bundles.
Kitu Kenya tunanunulia bundles bana, mimi niko mbaya.
Mangu sasa inaniambia ya fused 75%, so nimebakisha 25%.
Unatumia Airtel?
Bana Airtel.
Mimi hata bana Airtel ilikataa, ikanisinya, nikatupa simu, nikaasha hata.
Anjua simu leo. Hadi simu sasa inaniambia sijui your phone needs urgent protection.
Ai.
Alafu
Tung'ang'ane.
kesho class ya kesho ni saa ngapi?
Ya kesho siko sijui saa 2 ama nini.
Yeah. Hiyo kesho tuone venye kunaenda.
Alafu by the hiyo story ya watu wenye walikuwa na register hizo vitu za bundles, kwani kuliendaje? kitu gani? Hello.
Wewe kwani inaonekana?
Mimi sikuoni. Hapana, si lazima unini ushaendi uonekane.
Oh, ningeshangaa kama ningependa hata.
Mimi kwanza niliingia na kierere huko na vile niko na vest. Wacha nakwambia nilijitoa. Lakini wacha tuone. Si ile kama amesema si klasi itakana ishi kwa anaenda kufanya nini? Mimi zimeisha na mimi naenda atajipanga. Si bora maka tena.
Alafu wewe unafika kwa audio ya
Nasi nimefunga kwani what is this one?
Can you be able to hear me? Sorry, I tried login, but I could not be able to come in. Confirm if you can be able to hear me. The system had a breakdown. I tried to log in, it completely refused. Right now, is it a bit better? I've only seen Kelvin who has confirmed at least he can be able to hear me. The rest, anyone? The system has been having some issues. So yesterday and clear now. Not clear. Because I wanted just to say something before you go through the other notes about. Just wanted to say something about homogeneous equations. Or what we can do